8.3. I know the title of the lesson is Applying Deductive Reasoning. I am not going to be so concerned in our lessons in terms of you knowing the difference between deductive reasoning, which is using properties and laws of logic, versus inductive reasoning, which is looking at examples and patterns. I'm just going to require you to do it in terms of solving problems and writing proofs. So there are some key laws of logic that we need to understand. The first is the law of detachment. And that's that if the hypothesis of a true conditional statement is true, then the conclusion is also true. I often call this just like this is going to be kind of obvious. The law of syllogism is if you have a hypothesis and then you get a conclusion, and that conclusion becomes a hypothesis that leads you to another conclusion, then your original hypothesis can lead to your final conclusion. Kind of like if A is equal to B and B is equal to C, then A is equal to C, would be the law of syllogism. So going through law of detachment and law of syllogism. So use the law of detachment to make a valid conclusion in the true situation. If two segments have the same length, then they are congruent. You know that BC equals XY. So since you know that if two segments have the same length, they are congruent, then you know that BC is equal to XY. The second one, Mary goes to the movies every Friday and Saturday night. Today is Friday, so therefore Mary is going to the movies. Law of syllogism, to write new conditional statements that follow from the pair of true statements. So let's look at this first one. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A in chemistry. Therefore, that we can assume that if Rick takes chemistry this year, he's going to get an A. For the next one, if x squared is greater than 25, then x squared is greater than 20. If x is greater than 5, then x squared is greater than 25. So we can also assume that x squared is greater than 20. And on the last one, if a polygon is regular, then all the angles in the interior of the polygon are congruent. If the polygon is regular, then all of the sides are congruent. This last one would not be an example of the law of syllogism because if you notice here, we took the hypothesis, the conclusion, and made it the hypothesis in a new statement. Here in C, we are using the same hypothesis twice. So that does not follow the law of syllogism. Okay, so let's try some of these. I think it'll make a little bit more sense. If 90 degrees is less than the measure of angle R, which is less than the 180 degrees, then angle R is obtuse. The measure of angle R is 155 degrees. Using the law of detachment, what statement can you make? Well, it meets this criteria, so it is obtuse. If Janelle gets a job, then she can afford a car. If Janelle can afford a car, then she can drive to school. So you'll notice that the conclusion here became the hypothesis in the second statement. So we can take the original hypothesis, if Janelle gets a job, and link it with the final conclusion. Then she will drive to school. So state the law of logic that is illustrated. If you get an A or better on your math test, then you can go to the movies. If you go to the movies, then you can watch your favorite actor. So if you get an A or better on your math test, then you can watch your favorite actor. This is the law of syllogism because what was the conclusion in the first statement became the hypothesis in the second statement. X is greater than 12. If x is greater than 12, then x plus 9 is greater than 20. The value of x is 14, so x plus 9 will be greater than 20. That is the law of detachment. Sorry, they wanted the, which law you're using. That's the law of detachment. In geometry, you're going to frequently use inductive reasoning to make conjectures, and you're also going to use deductive reasoning to show that the conjectures are true or false, okay? You will not need to identify whether you're using inductive or deductive reasoning. You will have to state what process you are using or what property, okay? Here's just some practice on inductive and deductive reasoning. So what conclusion can you make about the product of any even integer and any other integer? So if I have any even integer, so let's say I have 2 times any other integer is 6. Now an even integer times an even integer is 8. So it's an even integer. I can start to see that anytime I take an even integer and multiply it by any integer, I'm going to get an even integer. Okay? Now, where I'm not going to be so worried about whether you know this is inductive or deductive reasoning, but each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball in the air, it will return to the ground. Okay? All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. So the first one was a pattern. It's inductive reasoning. The second one is deductive reasoning because it uses rules about laws of logic. Use inductive reasoning to make a conjecture about the sum of a number and itself. Okay? So 5 plus 5 equals 10, or -2 plus -2 equals -4. Many times you will have noticed that that's the same as multiplying a number times 2. So the sum of the number itself is twice the number. Using deductive reasoning, we're going to use n for any integer. So n plus n in algebra is going to give me 2n. It's not n squared, it's 2n. So as I said, I am not going to ask you are you using inductive or deductive reasoning. I am going to expect you to be able to make logical arguments. So use the law of detachment to make a valid conclusion in the true situation. If 2 angles are complementary, then the sum of their measures is 90 degrees. Angle C and angle D are complementary, so we can assume that the sum of their measures is 90 degrees. The law of syllogism to make a valid conclusion. If water is at room temperature, then it is a liquid. If water is a liquid, then it is not frozen. So if water is at room temperature, it is not frozen. Use the true statements below to determine whether the conclusion is true or false. Explain your reasoning. If Janine does her homework, then she goes to the movies. If Jaquan goes to the movies, then he buys popcorn. If Janine goes to the movies, then she buys popcorn. Janine does her homework, so she did her homework. Therefore, she's going to the movies. Therefore, she is buying popcorn. If Janine goes to the movies, Jaquan goes to the movies, okay? Janine does her homework. It just says that if Jaquan goes to the movies, then he buys popcorn. It does not say that if Janine goes to the movies, Jaquan is going also. So that's why that conclusion would be false. Okay, for homework, I think I'm only giving you problems 4 through 12. I just want you to be able to use law of syllogism and law of detachment, and I hope you have a great weekend.